Let's get started here, huh? All right, we got a couple of things to do. Oops, let me do that. So we're going to start by talking about course selection for next year. So everything I'm going to talk about, I've kind of like summarized here on the My Notre Dame page. So if you forget what I said, you always come back and look at it again. For rising seniors, come on in. You really have 5 things to choose from. If you're a current senior, you can just like zone out for 10 minutes or whatever. So you have 2 classes that ostensibly have no prerequisite. That's accounting 1 and 2 and math apps and personal finance. Both those are 4.0 classes. Relative to what you've been doing in here, should be quite easy. There's IB Math SL, that's a 5.0 scale class, possible college credit. The prereq is B or better both semesters of this class. AP Statistics, again, 5.0 scale, possible college credit. The prereq is B or better both semesters of Honors Algebra 2. Who's probably got that? And then AP Calculus, 5.0 scale, possible college credit, prereq B plus or better both semesters of this course. Open to seniors only, so no 11th graders allowed. Not that there's any 10th graders in here right now because CJ's gone. In general, all these are good classes. My general advice to you guys is balance your schedule, right? Like, if you're not a math person, don't try to make your class you're going to have to spend the most time on your math class. Like, pick a math class that, like, you're either going to love doing it, because it's like, yeah, this is my jam, that's what I like. Or it's one that's like, yeah, this should be pretty easy for me. And I can now spend more time working on, my lit class or my history class or whatever it is that kind of like fills me up a little bit. You know what I mean? Like in general, like the IB class, the first half is pretty statty, and then the second half is just kind of like a survey of a bunch of different topics, ranging from like pre-calculus and algebra 2 topics to trig topics to a little bit of calculus, even some geometry kind of topics in there. AP Stat is all stat all the time. I would say it's pretty on par difficulty-wise with like this course. I think the hardest things you do in there aren't decidedly harder than the things we do in here. The AP Calc class is probably the hardest of the 5. Mostly because it relies on really pretty good skills from a bunch of your previous courses. Like your algebra skills have to be really pretty good, and your trig skills should be pretty good. And it's not very forgiving in that way. If you're somebody that's interested in, like a college major involving mathematics or engineering or computer science or any of these kind of like STEMier fields, the AP Stat or Calc classes are great ones. If you're real engineering, the Calc class is probably the better of the 2 to choose. If you're like, and it just kind of depends. Like if you're interested in like medicine, even I think a lot of pre-med tracks require up to Calc 2 from college. So again, the AP Calc class maybe not a bad place to get some background there, especially if you think that's going to be kind of a weak spot for you, right? But it just, again, my advice to you is just like try not to give yourself an aneurysm your senior year by taking like all of the hardest classes possible and then try to play 3 sports and have 22 activities and a part-time job and a boyfriend and, like have a nervous breakdown by the end of September or something. You know what I mean? Like just be sensible. In general, though, do you guys have questions about any of these courses specifically? Elena?
The IBSL class has an exam too, right?
Correct. Yeah, you'll have an IB, a standardized test at the end, and you have to do a paper. You have to do an internal assessment, which is like a paper for that class as well. And I'm not sure exactly how the colleges do the college credit for the test for the SL courses. I don't know always how that works out. I think it's probably less so than the AP course credits that they hand out, but there is one there. I think it's actually 2 parts even. Joe? Well, I'm teaching the AP Calc class this year. I expect to do that the same next year. Miss Garcia traditionally teaches the AP Stats class. I don't know who's going to be teaching the IB SL course, to be honest with you. I'm not even sure who has it right now. I think Miss Garcia might have gotten it back. I think Miss Moody had it for first semester, and then they switched. Math apps and personal finance. I think Miss Morgan has this right now, and that one tends to kick around a little bit across the department also. And Miss Beauchamp was the one that used to do the accountings, and she's gone. I don't know who's going to do that in the future either, so I don't have a great... The first 2 I can tell you, I can give you a pretty good idea, and I don't have a good answer as to who's going to be doing the other ones. If that helps. It's something, right?
It does,
yeah, sure. Anybody else? If you have individual questions or you want to talk about yourself and what you want to do, feel free to stop by and talk to me. I'm happy to do that. But I think you guys do your selections tomorrow. Is that right? Do you even know? I'm not even sure.
Yeah.
I have freshmen in CT. They do theirs on Friday. I know that. Okay, cool. But anyways, all that stuff is up there, so if you want to go take a second look at it, I compiled it all in one place for you. Great. So this is, last time we met was the snow day. We were supposed to have kind of the Chapter 9 review day, right? I'd like to spend a few minutes anyways and see if you guys have questions from Chapter 9 stuff, and I'll talk a little bit about the test format for Chapter 9 also here while we're at it. So the test format for Chapter 9, you have 7 total questions, but like, get real, it's really like 20 questions or 30 questions or whatever, because they all have multiple parts. So you should be able to do things like calculate the lengths of segments in 3D figures and find the angles inside of 3D figures and calculate surface area and volume for 3D figures and compound figures. By compound figure, I mean like, if I have a cylinder with like a hemisphere on each end of it, so it looks like a pill, should be able to, volume and surface area for that. But, it's like, whoop-de-doo-doo. And just break it apart into a couple pieces. There will be like 2 big multi-part questions, like the last, 2, 3, 4 questions from the problem set. But you get if you haven't looked at the review packet, you do get at a massive equation sheet for this chapter. So if you look at the end of the review packet or whatever, it's like, ooh, look at all that. I think it's basically everything you need, but if it's not on here, it's not on the test. But I think everything you need is probably on there. There's a lot of stuff. Any test format questions, stuff? Okie dokie. Did you guys have some Chapter 9 stuff? I think for the snow day, I'd asked you guys to work on your problem set and the and the review for Chapter 9. Do you guys have anything you want to talk about from there? Happy to do a couple if you guys got some that are still kind of, we're stuck on or not sure about, or want to just like, I think I did that, but maybe not, Morgan, is that a hand, or is that just like, yeah, that's okay. We're not in a big rush, like little rush, but not big rush. from the problem set? Yeah. Certainly. Oh, that was a good one. I guess it should probably go without saying, but a lot of the situations for the problems on the test will be similar to the situations you're going to see in the problem set in the review. So if you would be really well rewarded of spending some time and making sure you know what to do for the situations that you've seen before. All right, so here it says the diagram given shows a cylinder with radius 20, height 60, and C is the midpoint. So we know that like that's 30 and that's 30. It asks us to find the value of angle X, and they drew in this nice pretty pink triangle here. What do you notice about this pretty pink triangle they drew in? It's not a right triangle. So if I'm going to use that pretty pink triangle, I'm going to have to use the law of sines or cosines, right? I'm not going to do that. I'm going to do this all with right triangles, I think. So I noticed that angle X would be the same thing as angle DAB minus angle CAB, right? Let's use that. Everybody agree with that? And the advantage there is that both DAB and CAB are inside of right triangles, so I don't have to break out the crusty old law of sines or cosines to do that. So side AB is 40, DB is 60. So angle DAB is just going to be tan inverse of 60 over 40. Similarly, if we have angle CAB, AB is still 40, but CB is 30. So angle CAB is going to be tan inverse of 30 over 40. Does that feel okay there? Yeah. And I'll let you grind through the buttons on the calculator, but that's good enough, right? Yeah. And then if I look at angle Y then, I notice that angle Y is going to be a linear pair with angle ACB. You guys agree with that? So I can just do that. And angle ACB, I notice, is just going to be the complement to angle CAB, because they're both the acute angles inside of one right triangle. And I already have CAB from before, so there we go. Does that feel okay there? Yeah. Not bad, right? Cool. Anybody else? Happy to do more if you guys want to talk about more stuff. Ariana. 31. Sure. Is that that's the big one, right? Sure. All right. It says a shipping container is made with 6 rectangular faces as shown. The dimensions of the container: length is 2x, width is x, height is y. All measurements are in meters. The total length of all 12 edges is 48. And it says part A, show that 12 minus, or that y is equal to 12 minus 3x. So this is the piece that I'm going to be using to get that. So if I go and look at my figure, how many side lengths do I have that are equal to x? I have 1, 2, 3, 4. And then how many side lengths are equal to y? 1, 2, 3, 4. And then how many are equal to 2x? 1, 2, 3, 4. And all of that has to equal 48. So if I add that together, I have x plus 8x, or 4x plus 8x, that's 12x. If I get the y by itself, I'll just subtract that 12x over and divide everything by 4. That's what we needed to show. We did it. Yay! Show the volume for the container is that. Well, I know the volume is just length times width times height because it's a box. And we know the length is 2x. The width is x, and the height is y. But the thing I'm shooting for doesn't have any y's in it. So I need to get rid of the y in there. How am I going to do that? Well, y is 12x minus 3x, or 12 minus 3x. Oh, okay. And if I FOIL this through, I get 24x squared minus 6x cubed. Oh, there it is. Look at that. Boop. So far, so good. There is no C. I don't know why. On to D. On to D. It says find the x, or the value of x for which v is at a maximum. Well, to do that, I'm going to just graph this on my calculator and see where the highest point is. So 24x squared minus 6x cubed, okay. And the x's, well, what can I say about the values for these x's? Certainly have to be positive, right? Because they're a length. And definitely have to be less than 48, since I know all of the sides add up to 48. So I'm just going to, I don't know, I'll go 0 to 20 or something. And I don't know what this volume is going to be. I'll just do like 0 to 100. I can always come back and adjust if I need to. Do that. Oh, look at that. There's my maximum right there. So to find that, I'll just do second trace, use the maximum command. And left bound. Notice I'm like way down in the negatives here, so I just got to keep moving over till I get there. I see it. Okay, that looks good over there. Press enter. Get a right bound. That looks good over there. Press enter. Guess. So 267. And I think these were all in meters, right? Yeah, 48 meters. It says find the maximum volume for the container. Well, I have that right here, right? Remember the y was my v, so just 5689. Well, that was easy enough. F, it says find the length and height of the container. Okay, well, I know length is 2x. So that's going to be 2 times 2.67. So that's like 533 or 34, I guess, since I rounded. And the height is y, which is 12 minus 3x, which is 12 minus 3 times 6.7. And that's got to be about 399 when I type that through. Cool so far? Okay, and I think we got just one part left, right? Oh boy, look at all this words here. All right, it says we're going to paint this shipping container. 1 liter of paint covers an area of 15 square meters. Paint comes in tins containing 4 liters. Calculate the number of tins required to paint the shipping container. Okay, well, I'm going to calculate the surface area for the container. So that's just going to be 2 length times width plus 2 length times height plus 2 width times height. So that'll tell me how much surface I have to cover with paint. So 2 times 2.67 times 5.34 plus 2 times 5.34 times 399 plus 2 times 2.67 times 399. So that gives me 9244 thereabouts. And I know that 15 square meters is 1 liter of paint. And I know that I get 4 liters paint in 1 tin. So I can just do that dimensional analysis there like a chemistry problem and just figure out the number of tins that I need. So divide that by 15 and then divide it by 4. I get 1.54. But do tins come in 0.54s? How many tins do I need then? 2, right? I'll just have a little bit of leftover paint, but I can't paint it with 1. Won't be enough. Does that feel okay?
Yeah.
Looks so easy when I do it, doesn't it? It's okay if it's hard. It's a product of me having done the problem, I don't know, 24 times in my life. It looks really easy at some point. You know what I mean? Anybody else? Talk about anything else? Happy to do it. If you don't, that's okay. Alrighty then. Today then we'll start chapter 10. I think chapter 10 might be my favorite second semester topic. So in 10.1, we're going to talk about parametric functions. And we're going to start with just like a little bit of a sidetrack to kind of frame why we care, or what the motivation is for like worrying about these things. So let's go back to like algebra 1. Let's say we have the equation x squared plus y squared equals 1, which is just the graph of a circle, right? Is this a function? Is the graph of x squared plus y squared equals 1 represent a function? No, why not? Yeah, okay, because it fails the vertical line test, right? Now, what about failing the vertical line test? How does that like break the definition for a function? Okay, so let's rephrase that and just, instead of saying x's and y's, let's use only input output, right? So we're not a function because one input has 2 outputs. right? And almost any input you choose, that's the case, right? Are there any inputs where you still get just one output? There's two of them. Yeah, 1 and -1, right? When x equals 1, y has to be 0, and that's the only answer you can have. And -1, and x is -1, y can only be 0. That's the only possibility. Okay, so clearly this is not a function, right? Now, what if I want to find a new way to define this circle so that it meets the attributes or meets the definition of a function, where any input has exactly one output? How would I do that? Well, instead of writing this as like a y equals f of x, that's not going to make it as a function, right? Because x's are the inputs, and that's going to be a problem because every x that I pick, almost every x I pick is going to have more than one output, right? So what I'm going to need to do is I'm going to have to define a new variable to act as my input. I'm going to call that variable t. And then I'm going to define the x coordinate as some like, let's use g of t, and the y coordinate as some like h of t. So what we're doing is we're taking a t and mapping it to an xy, as opposed to over here where we take an x and we map it to a y. So what we're going to do is we're going to create a function where we have some input, t, and the output, instead of just being a number, is going to be an ordered pair. And if I do that, now I can create things like that fail a vertical line test, but could still be considered functions, because my input now is not the x coordinate, it's this other value t. What do you guys think? It's like a cheat code. It's a little workaround, right? It's like, Mr. Cool, this feels like cheating. And it's like, oh no, man, it's not cheating. In fact, we've done this already. You just didn't realize that we did it. All right. So let's write this up as a formal definition, this idea that we've had. So the graph of the ordered pair xy, where x is some function of t and y is some function of t, are functions defined on an interval I. Those points formed are called the parametric curve. So the result of f of t here that we've drawn up above is a parametric curve. The two functions for x and for y are the parametric equations. So up here, x equals g of t is a parametric equation, and y equals h of t is a parametric equation. The variable t, so the t that's like the independent variable in this function, is called the parameter. And I, the values of t that we're going to consider, is the parameter's interval, is the interval for the parameter. So let's just do a little example here. So here we have the function x equals t squared plus 1 and y is equal to 2t, where t is going to vary from -3 to 1. So if I wanted to graph this, I'm just going to make like a TXY table. The values for t that I'm going to choose, well, I'm just going to be like obvious and use like integer values that are inside that interval. When I plug -3 in for t, I get 9 plus 1, so that's 10. And I get -6 for y. And then I get 5 and -4. And I get 2 and -2. Then I get 1 and 0. And then I get 2 and 2. So if I wanted to then graph this fella, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we gotta go 6 down. 1, 2, 3, 4, 5, 6. So let's see, we have 10, -6. We have 5, -4. We have 2, -2. We have 1, 0. And we have 2, +2. So there's what my curve would look like. Notice, does this curve pass a horizontal or a vertical line test? No. Is it a function though? Yeah. It's a function in terms of t, not in terms of x. Yeah, I see. Now notice that if I then wanted to change my interval over which t is, so this time maybe we're going from -1 to 2. Well, I already know that what these are because they're the same thing that we had before. When I plug 2 in, I get 5 and 4. Notice that basically what am I having if I change t? Just a different part of the same graph, right? I have a little bit more in one direction, a little bit less in the other because I didn't go as far negative with t and I went further positive with t, but like whatever. If I did this, so again, I already have my values for most of this. I've done a bad thing here. So that's going to look like that. You guys kind of see what's going on? Here's the nice part. Guess what you can do? I can graph this stuff on my calculator. You want to see how to do that? If you want to follow along with what I'm doing, go ahead and take your calculator out. If you just want to sit and watch, though, that's cool too. Whatever floats your boat. I'm a button pusher. I like to push along. But some of us are watchers, I know. All right. So we're going to start by pressing the mode button because we have to change the mode of our calculator. Notice down over here we have 4 options: function, parametric, polar, and sequence. Everything we've been doing so far in this class, we've been in the function mode. Since we're going to be graphing a parametric function, we're going to change that to parametric, P-A-R. And I do want to be in radian here probably for the rest of the class. So when we're in chapter 10, we'll be back to radians. Keep in mind that if you change that now, to remember to change it back to degrees before the test on Thursday, because all that's in degrees, right? So just be careful about that. All right, so I've done that. I'm going to go press y equals. And wow, look at that. It looks a way different, doesn't it? I have x1t, y1t, and that's all representing one function. So for x1, I'm going to do t squared plus 1. Notice what happens when I press the variable button? It wrote a t there. Notice the variable button has x comma t comma theta comma n. Depending on the mode your calculator is in, the calculator is going to automatically change the variable for you. That was really nice. How considerate. So I'll do t squared plus 1, and then 2t. Okay. Now I'm going to have to change the window. The thing I really care about is the t min and t max. That has to match the interval. So I'll do -3 to 1. And then I'm going to fix this all back to just kind of like a standard -10 to 10 window for x's and y's. Since I changed all that stuff when I just graphed that problem for Ariana a minute ago. So just re-put all that stuff back. Okay, hit graph. Boom. There's my red graph I got there, right? If I change that now to go from -1 to 2 on the t's, I'm going to get the green graph. Boop. And if I change that to go from -2 to 3, I'll get that orange graph. That's pretty neat, right? Very easy to use. How considerate, graphing calculator, that you made my life so simple. Do you think I had this option when I was a student? Nope. Guess what we did? All of it by hand. All of it by hand. It was El Stinko. All right. So let's do another, right? Oh, well, before we do that real quick, what if we just wanted to graph this over like all real numbers? What's the shape of this function going to be? If t can be any real number. What do you think I'm going to get out of this? You know what? That was the first guess in 5th hour also. That's not quite right. What I'm going to get is a sideways parabola, which hopefully should make sense considering the x is a quadratic and the y is a linear. So I should expect that to be a quadratic that's opening, left or right. Possibly. There's actually 4 possible things you could get out of it if they're both quadratic. You could get a circle, you could get an ellipse, you could get a hyperbola, or you could get something else. I forget what the other thing is. But there's, I think, 4 different types of conic sections, and that's what you get is some kind of conic section. So just like a piece of a cone. If you take a slice of a cone and you look at what shape you get. So if it's like perpendicular to the base, it's a circle. If it's a diagonal, it's an ellipse. If it's like straight up and down, you get like the hyperbola thing out of it. Like, I forget what the other one is, what you have to do to, anyways. It's getting beyond the scope of what we're trying to do here, but yeah, so there we go. That's pretty neat, right? Let's do another one here where we'll just kind of practice using the calculator. So let's say we want to graph the parametric equation where the x is sine t and the y is cosine t. Before we type this in, what do you think this is going to look like? You guys should know, because we kind of already did it. Yes. So remember the unit circle from semester 1. The coordinates of the unit circle were cosine comma sine. Here, it's sine comma cosine. Is that going to make a difference? So remember, like, when we talked about inverses last year, those are a reflection across the line y equals x. We've swapped the x and y coordinates. If I reflect the circle across the line y equals x, what do I get? The same circle. Yeah. So certainly should be a circle, and it will be a unit circle because the radius is 1, because, again, the maximum value of sine and cosine is 1 each. Let's just type that in. Now, there is one little catch here, because, stop. What haven't we been given? The interval over which to graph t. Yeah, what would be a reasonable interval to use for this problem? What do you guys think? I'd start with 0 for sure, but not to 1, not to 10. What? Ben? No? Someone whispered something, I thought. Connor? No. Pi is close. 2 pi. Why 2 pi? Because that's the unit circle, right? The unit circle goes from 0 to 2 pi. Will generate the entire unit circle. We're doing sine and cosine. The fundamental domain, or the fundamental period of sine and cosine, is 2 pi. And in fact, any 2 pi long segment would be okay, whether you want to go from 0 to 2 pi. Gives me a unit circle. Or if I went from like 1 pi to 3 pi, I just get the same unit circle. Or even if I just pick anything that's bigger than 2 pi, or anything that's longer than 2 pi, like negative 10 to 10, still gives me the same picture. Why is it still giving me the same picture? Even though I have more than 2 pi of t's there? Because it's just like drawing it, and then drawing it again, and like drawing it again, right? And it just keeps drawing, and it'll leave off somewhere in the middle, but it doesn't matter. You just draw in the circle a bunch of times. You get what I'm saying? That's kind of neat. All right. So we've established that we have like these parametric functions. And we have our Cartesian, our normal functions we've been talking about before. What do you suppose we're going to want to do now? Yeah, talk about going back and forth, right? So to go from a Cartesian function, or I'm sorry, from a parametric to a Cartesian, we call that eliminate the parameter is the command we call that. And to go from Cartesian to parametric, we say that's parameterize. Is the name that we give to those things. Let's do some command or some examples of eliminating the parameter, and then we'll do some examples of parameterizing. All right, here we go. So if I want a Cartesian equation, what's it start with? Y equals, right? So my plan here is I'm going to take my x and get the t by itself and then plug it into the equation for y, hence eliminating the t's. So just subtract 2 from both sides. We'll divide by -3. I'm going to push that -3 up through the numerator. That's why the numbers are switching spots in the subtraction and the negative sign disappeared. And then I'm going to plug that in for t in my y equation. And I'll push that negative through the fraction. And then make a common denominator. And then I'll just rewrite this as that.
Wait, Mr. Cool.
Yes, sir.
I'm sorry, why'd you switch 2 and x?
Well, I just, here?
Oh, the other part, you went x minus 2.
Yeah, because I divide by -3.
Oh.
So I pushed the negative sign up into the numerator just so I didn't have to like write a bunch of extra symbols.
Yeah.
It's 6 of one, half dozen of the other. You can put the -3 down there and not switch them. It's fine. Right. Just less symbols for me to write. So what shape of function do we have here? What kind of function is y equals 1/3 x plus 1/3? What kind of graph is that? What's that look like? This is like Algebra 1 stuff. Yeah, it's linear. It's a line, right? That's just y equals mx plus b. Everybody feel like we're done? There's one thing we have to worry about. What we've said is that this function is equal to this function, right? For that to be true, they have to have the exact same domain and range. So what I need to check here before I can say I'm done is I need to figure out the domain and range here. And make sure that that's going to match or make the domain and range for the Cartesian one match that. So my inputs here are t from -infinity to +infinity. If t can be -infinity to +infinity, what are the possible outputs for x? What values can x take if t can go from -infinity to +infinity? Any value, right? You can go from -infinity to +infinity. Agreed? So the domain then, -infinity to +infinity. How about for the y? Again, the t is any input from -infinity to +infinity. What are the possible outputs of y? That's right, -infinity to +infinity. What kind of function is x? It's a linear function, right? I know the domain and range for a linear function are both all real numbers. So the inputs t are all real numbers. The outputs, the x's, should be all real numbers. What type of function is y? Also linear. If the inputs for y are all real numbers, then the outputs for y should be all real numbers. If I look at my Cartesian equation, what's the domain and range for that? As it's written? All real numbers for each, right? So we're good. The domain and range for the parametric matches the domain and range for the Cartesian. There's nothing more for me to do. So fine, write the way it is. I could write, the domain and range with it if I wanted to, but I don't need to do it. Let's do another where we do have to worry about that domain and range here. And I think this thing we're about to do is like the single hardest skill in this chapter. So again, it says eliminate the parameter. So I'm going to start the same way. I'm just going to take my equation for x and solve it for t. So divide both sides by -4. I drop that in here for y. That's going to be 1/8 x squared plus 1. What type of function is this? Quadratic. Very good. How'd you know? Yeah, it's a polynomial that's degree 2. We call those quadratic because of the x squared. Everybody feel good so far? No big deal. Now here's the tricky part. Notice, what do you notice here? The inputs are not all real numbers, right? The interval for our parameter is not all real numbers. Here we must be careful. So if I want to look at the possible outputs for x, all I really care about are the endpoints of my interval. Is everybody okay with y? Why don't I care about any of the values in between -2 and 4? Why doesn't 0 matter, or 2, or 1, or pi, or -√2? Why don't any of those values matter to me? Great. Why? Great. Why? Is it always that way for any function? No. What's special about the function x equals -4t? It's linear, which means it's always increasing or always decreasing, right? If it's always increasing or always decreasing, we call those kinds of functions monotone. If you have a monotone function, the maximum and minimum of it are just going to be the endpoints of the function, right? So that's all we care about here. So my domain then should go from -16 to 8. Now let's look at the range for our parametric. What type of function is the y function? Quadratic. Is that monotone? No. In fact, every quadratic function goes from like increasing to decreasing, or from decreasing to increasing, right? Everybody agree with that? So for a function like that, that's not monotone, I care about the endpoint still, but I also care about some other values. What other values am I going to care about? The places where we switch from increasing to decreasing, or decreasing to increasing. So in a quadratic, what do we call that point or that place where the graph changes from increasing to decreasing or from decreasing to increasing? What, Elaine, what did you say? It's not a zero. It is an extrema, but we have a better word for an extrema for a quadratic specifically. It starts with a V. It's the vertex. Yeah. The vertex of the parabola is the location of the extrema. That's where the graph changes from increasing to decreasing or from decreasing to increasing. That's exactly right. Who remembers how to find the vertex for a quadratic? Yeah, this is algebra 2. You guys did this. You can, but there's an equation to find it, just in terms of A, B, and C. So the x-coordinate of the vertex is going to be negative b over 2a. Should you remember that?
Yes.
Yeah, you'll use it in this chapter. So that's a good one to remember. So if we look at ours, our quadratic, what is the value for b? 0. And the value for a is 2. It doesn't matter because it's just 0, but yes. Everybody's cool? All right, so if I plug in negative 2, what do I get? I get 9. If I plug in 4, I get 33. I plug in 0, I get 1. So what is my range then? 1 to 33. Oh, hold on one second. Sorry, I didn't mean to scare you. Actually, I did mean to scare you, but we didn't check one thing that's very important that we check. Has to do with that location of the vertex. That location might matter, it might not. We need to check to make sure it does. How do I do that? How do I know if the vertex matters or not? This number has to be inside our interval for t. If it's not inside our interval for t, then I don't care what the value is. Right? Is 0 in between negative 2 and 4? Yes.
So if it isn't, should we just ignore it?
You would ignore it. Exactly right. Yes. So it would be, imagine like if I'm graphing like t comma y of t. That's like our function that we're graphing. So you have two kinds of things that are possible. Like you could have like this, where that's all you have, where the vertex isn't included. Or you could have something like this, where the vertex is in between, right? If you had the red situation, the vertex wouldn't matter to you because it's not inside it's not part of your function. You just have one decreasing piece. Oh, then it's fine. Who cares about the vertexes? Does that feel okay? Now, I fully admit, this is not obvious. This is not tremendously easy. It's very easy to get like turned around about, wait a minute, which function am I looking at? I'm doing the domain for what? This gives me what? It takes a little bit of practice. Once you get it, it's not difficult, but it certainly feels unfamiliar, right? It doesn't feel like anything you've really been doing before, because you're just jumping back and forth between these two different functions, and it's a little bit confusing in that way. You guys will do some more practice with this in the homework, and I'm sure that you guys will end up asking me about it because, well, we do this, we ask about it every year. Let's do another. So let's look here at this one. So it says, again, eliminate the parameter. Okay. So I would just get x by itself, right? So, or the t by itself. So what would t equal? Cosine inverse of x over 3, right? And I'll plug that in for the t, so I have y equals 3 times sine of cosine inverse of x over 3. Yuck. That doesn't seem right, does it? Doesn't seem right to me either. What shape is this function going to be? Yeah, it's going to be a circle again, right? Everybody agree? Because it's the x-coordinate is cosine, the y-coordinate sine. That should be fairly obvious. So who remembers the equation for a circle from geometry? That's one you'll use. And if you don't remember that, you'll want to make sure you have it written down because you'll use that in the homework. Okay. What's the center going to be for our circle at x equals 3 cosine t, y equals 3 sine t? Just going to be the origins, though, right? This is just a unit circle that's been going to be stretched out because we're just multiplying the x-coordinate by 3 and the y-coordinate by 3, right? So just going to be like a bigger circle, but the center will still stay the same because everything is being just stretched. You guys all buy that? Okay. So we're going to have, it's going to be x squared plus y squared equals something, right? Well, what is x squared? That's just going to be 3 cosine t squared. And what is y squared? Well, that's going to be just 3 sine t squared. Okay, well, okay. It's going to be 9 cosine squared t plus 9 sine squared t. I notice that, hey, there's a factor of 9 in common there. And wait a second. I see something. Do you see it? Yeah, cosine squared plus sine squared is 1. That's a trig identity from first semester. Oh, those still matter? Yup, they do. You can't forget, guys. You're not allowed. And 9 times 1 is just 9. So x squared plus y squared is equal to 9. There's my equation for my circle. Oh, neat. What's the radius then? 3, right? Because 9 is 3 squared. Yep. Well, that's not so bad. All right, what if we want to go the other way? What if we now want to start parameterizing a Cartesian equation. This one should be your best diddly darn friend here. So if I look at my Cartesian equation, do I notice that x and y are just in one place, right? And the x or the y is already by itself. So I'm just going to say, okay, what if x is just acts like my parameter? Then y should just be the same thing with the t on it, right? The last thing I need is just decide my interval for my parameter, which should be the same as the domain for my Cartesian function, right? What kind of function is y equals 3x minus 2? Linear. What's the domain of a linear function? All real numbers. So the interval for my parameter should just be all real numbers, and I'm done. It was that easy. Well, that's swell, Mr. Kulik. I love it. Okay, can you make it harder for me? Sure I can. What if we're looking for the parameterization for the line, but instead of giving you the Cartesian equation for the line, I just give you 2 points. What would I do? What could I do here? What'd you say, Elena? You mean like write the y equals mx plus b equation, then do that? Yeah. You could do that. That's fine. There's an easier way, though. So what you also could do is you can use your vector equation for a line. So remember there that we have that. So there's my vector equation for a line, right? Just do head minus tail, and then pick one of the points to act as R naught. Doesn't matter which one. Yes, sir? Absolutely. If I do my vector operations here, and I do my scalar multiplication vector addition, I have that, right? Guess what that is? That's my parametric equation. That's my equation for x and my equation for y. And because this is a line, t is still going to be, the interval for t is still going to be all real numbers. Well, that wasn't so bad. I love it when something I've used before just circles around and works for the next chapter, right? Isn't that swell? Mr. Kulik, can you make it harder than that? Well, yeah, sure. Find the parameterization of the line segment through the points, yada, yada, yada. Wait a minute, Mr. Kulik. Isn't this the exact same question as the previous one? Why is this harder? What's different? Yeah. What's that going to change? The interval. Very good. Everything else is going to remain the same. We'll still start this the same way. Let's just cut down on some of that. So we did that, right? Everybody's okay? Now here's the big advantage of using the vector line equation to do the parameterization, rather than doing what Elena had suggested, which again is a perfectly okay suggestion, and it's the one that I expected you to give me. It's exactly what I expected you to give me. Here's the beautiful part of this, is that there's only two possibilities for this. My interval is going to be either 0 to 1 or -1 to 0, assuming that I'm using the vector line equation to do my parameterization. If I do what Elena had suggested, it's going to be different every single time. You're going to have to solve it algebraically, and it's going to be kind of a pain. This is just a check. So if I plug 0 in for t, I get -1, 4. Well, that's fine. If I plug 1 in for t, I'm going to get -8. For x, that's not the one I want. Must be this one. That easy. Do you need to see it again?
Could you explain why it's -1, 0? Just really quickly.
Yeah, so I'm checking here. I just started with the 0, 1. If I plug 0 in for t, I get -1, 4, which is fine. If I plug 1 in for t, I'm going to get -8 there, which is not 6, right? So it doesn't work. So the other one has to. Because there's only two options if you're using the vector line equation. It's either 0, 1 or -1, 0. If you plug -1 in, you're going to get 6, -3, which is exactly what you're supposed to get. And again, 0 gives you the other one. So that's that. Now, keep in mind here, folks, that if you'd done the other way, if you had subtracted D, or if you subtracted C from D, and you got 7, -7 here, you're going to get the opposite interval. That's fine. Both answers are correct. But if your parameterization is different, your interval here could be different. So don't be freaked out if it's like, hey, we both did it, we got two different answers. It's okay. It could happen. And that's all we have for section 1 here. Here's the bad news, is we're looking at 1 through 40 as the first set of problems. The good news is none of that stuff's due this week. That would all be for next Sundays. Whatever that date is, the 12th or something. Yeah. What do you guys think? I think this stuff is fun, but I'm a math dude, so if you're not a math bro, I don't know what to tell you. Okay.